This is the report of the field trip to the Air Quality Monitoring Station, University of Lagos, Nigeria. This field trip was on Tuesday, the 24th day of March 2026, and was led by our dear lecturer, Professor Alani, and the trip was meant for all her master's students offering environmental chemistry and chemical pollution. The cohorts in participation were environmental, analytical, and education chemistry. I am Victor Odom, a participant reporting on behalf of all the students. Professor Alani was excellent in bringing the abstract and theoretical class lessons to life by explaining the operations of the reference monitor, low-cost sensor, even the collocation of the low-cost sensor with the reference monitor for accurate real-time pollutant analysis in the environment.
So you can see they're working. We can see NO2, you can measure very accurately and very valid data. The ones that we can use easily and carry around, these are what we call low-cost sensors. I think I mentioned that it's measuring real time. All these ones are measuring real time. If you look at it, you just see every minute or so at a stage. Yes, it will change. Something maybe is happening. Maybe like we are here, we are maybe more so things will change just like that. So it's just every less than 1 minute, it's just changing. So it's a lot of loads of data. So it's real time. It is good to co-locate those ones with reference monitors. Co-location is just mounting your low-cost sensor that you want to use close to the reference monitor on the same environmental condition. So even though all these have been calibrated, the low-cost sensors have been calibrated very well by the manufacturers, wherever they came from, US, India, and everywhere, they've been calibrated and validated, but the environmental conditions are different. In the US, here we'll be shivering and covering ourselves, but here it's different. So we have to co-locate the low-cost sensor at that same location. In Nigeria, the situation is okay. It's just almost the same everywhere. Now everybody's complaining of it. So, and then the difference is really not that much. So anywhere in Nigeria can come. Anyone can bring his low-cost sensor anywhere from Nigeria. Nigeria can come and co-locate here because they don't have any other place to be able to go and validate their low-cost sensor.
And the passive sampler for collection of heavy metals pollutants like mercury, lead, cadmium, and others for laboratory analysis.
So this is passive sampler. So what we do is we clamp it, and then like described in the class, you see the silicone covers it, but there is space. The space in between doesn't close the whole thing. You can see the one under is smaller than the one on top. So, and then the air passively, that's why you have passive sampling, passively moves around. Even if it rains, so nothing happens, nothing touches it. The dust, the particulates, the whatever is collected, it adheres to this polyurethane foam. It's already treated, and so what we do, we use forceps and grab it and fix it here. So this holds it in place, and then we cover it.
In all, it was a didactic and exciting time with Professor Alani. In her words, she would say,
The more you smile, the more the
I'm the one wearing red.
thank you for watching.